Good morning, everyone, and nice to see you all again. Today we'll talk a little bit about synthetic aperture radar yet again, and most of you have already seen the presentation by either Felix or by Simon and Eigil, so hopefully all of you know somewhat what synthetic aperture radar is. So today we'll not go into much detail of the SAR sensors. Instead, we'll talk a little bit about the vision, the current state, and the roadmap of this SARProcessing Julia package that we are developing. And currently we are 4 people working on the package, and since all of us are here in this very room, we'll all go up here and talk a little bit so you can see us all. And it's not only just a presentation of us, it's also like kind of an open discussion where we want you to actively contribute with a little bit of things or knowledges that you have of especially Julia. So first and foremost, these synthetic aperture radar images, as we recall, are these complex images with both intensity and phase. So they are actually very complex to process. I don't know if you can recall the workshop or the hands-on that Simon did with interferometric SAR. There was a lot of processing steps there. That's just one derived data product from SAR images. So there's a lot of processing steps in it. So it takes quite a bit. And so why do we then want to do it in Julia? And why do we then want to make SARProcessing.jl? Well, if we look at the already existing methods of handling SAR processing, there are quite a few, but they all have some disadvantages. And of course, what we'll do in Julia will not. But first and foremost, we have the commercial software that is quite expensive, actually. It's not transparent, and it's difficult to integrate in other processing chains. Obviously, there are a lot of algorithms where you can change specific parameters in these commercial things, but you cannot actually change a whole lot of the algorithms. And yeah, expensive. Well-known examples of these are the Gamma software for interferometric SAR. We have the consultancy Altimeter and MATLAB. MATLAB you cannot even do all of the SAR processing in, so that's just also part of it. Then we have other non-commercial software, likewise not transparent, difficult to integrate. A classic example is the ESA Snap desktop that I think most people are actually using when they initially try to use SAR images. And while you can see a lot of the functions, you cannot, for instance, see the source code. It's buggy, it's slow, it's difficult to integrate and whatnot. And then we have different open source alternatives. And we have not yet seen a full processing chain of SAR processing in any of the programming languages that we know of. It's always where you have to like take bits and pieces from, for instance, the commercial software. And we also have that 2-language problem that a lot of the things that have been implemented in, for instance, Python, is like using all the C implementation. A good example of that would be something that is called PyGMT SAR, which is just a Python wrapper for the C library, GMT SAR, and all it's doing is making interferometry. So to our knowledge, at least, there does not exist this, how can you say, open source framework where you can do the full processing of SAR data. This is what we envision in Julia. The vision is to have a full ecosystem in Julia for the full processing chain of SAR data. Now, when we say ecosystem and when we say processing chain, we mean something like this. We want to have some package. This is the SARProcessing.jl, where you can get the raw data depending on what raw data it is you want to get. You can do the pre-processing and you can get some kind of data that you can then use. This could be, for instance, the interferogram that we showed the other day. And then the ecosystem part here is also that it's very much indeed user-driven, such that we have a framework where you can get the data and you can make all of these applications yourself, and you can then contribute to the ecosystem. And it's here very important to say that in this vision, the SAR processing is just a part of the ecosystem. So processing is like obviously all of these things that you can see here, taking the raw data, processing it into data you can use. And then another part of the ecosystem could be all of these really, really neat applications that in truth is actually what people want and use, like velocity maps and deformation and all of these things. Moreover, we want it to be transparent, easy to inspect the source code and decompose the different processing steps. This is indeed very difficult in much of the external software. And therefore, we actually want to remove this need for commercial software, which is used a lot in SAR processing around the world, we think. We want it to not only be usable, but actually to be used for applications. Such that if you are a company and you are developing some algorithms, applications, we want people to use this framework. But we also want it to be an ecosystem where people are developing new SAR processing algorithms. In fact, that's how we see it being developed, because it's very technical to develop some of these algorithms, not only due to the software side of things, but also just the SAR complexity. So having people that knows a lot about SAR wanting to develop new SAR processing algorithms is how we move this forward. We want it to be user-friendly and in one language. No need for SAR, for C or Python or whatnot. Yeah. And now Simon will take over and explain to you about our current state of things.
Yes. So now we're presented a little bit about the vision and where we want to go with SAR processing, and also just building up a SAR ecosystem in Julia. I'm going to briefly touch upon like what is the current state of this package. Yeah, first of all, I think if you attended the hands-on session on Tuesday, you will have like a little idea of like what the state is. But the state is that we're somewhere a good place between a proof of concept and a finished package. So currently, this is actually just taken from the folder structure. But we have different parts of the SARProcessing.jl, and which part we kind of have involved have been motivated by the fact that Eigil and I, which is two contributors, we already had a part of some Julia code for doing interferometric SAR. So the vision was a little bit to go with that and to get something quite useful and quite advanced out in a relatively short time to show these capabilities. And yeah, a big part of the interferometric SAR is about the geocoding and stacking on top of it. It is like a fundamental process. And that's actually a place where we spend like a lot of the energy to get this out and get it in a state where we can show something. There's still need to go through some of these steps and like test them even further, especially like when we go to the INSAR part to validate that the results are correct. Talking about the sensors. We have previously worked with the Sentinel-1 satellite from ESA, and the data here are freely available and quite easy to access. So we thought that was like a good place to start with the sensors, but we have a clear vision of it being extendable to other SAR systems. So we're not making this package is not called Sentinel1.jl, it's called SARProcessing, and that's part of the vision that we're going in that direction. Coming up here, we have some object detector, speckle filter, and visualization. This part have really been like the visualization have been driven by all of us, and it's because building this package and developing it and coming here and giving a hands-on session, working with images, it's quite sad if you're not able to show any of the images. I don't know about how you feel, but just looking at matrices and numbers in 2D arrays get very tedious very fast. So we prioritize to have like a bit of visualizations in the package. But that might be restructured a bit later. Yeah, and then we have the object detection speckle filter, and the reason why we started with those have been kind of twofold. So first of all, speckle filter and object detection is kind of like some fundamental things in SAR processing, which is used by a large part of the SAR community. That's like one of the justifications, and the other one is kind of the motivation with Christian actually using these processing step is his actual work. So in that sense, it makes good sense to kind of prioritize them, so we can get a package we're able to use ourselves. These 3 points are combined in like one combined red box, and it's because we imagine that we're going to do quite some restructuring around this. So right now it's directly included in the package, but these filters and object detectors and visualizations, they really also depend on a lot on other packages, and some of it may be at an advantage to separate out in other parts of the SAR Julia ecosystem once it gets going. Yeah. And then feedback on the structure. So like this is our current state, and it's like just how we started to do it. And right now, all our works have been fused into to one package, and that's also been just to simplify the way to get started. But we really would like if someone has some feedback on like how to get started with structuring a package like this and get going. So I don't know if any of you see this and have some major comments. You're welcome to put your hand up now. Okay, that must mean it's not entirely terrible what we're doing, and we can continue a bit down this road. So that's at least some comfort. Okay, now Eigil is going to present a little bit about our roadmap.
Hello. Yeah, so we'll just show you a little bit about the more detailed, like close, like a short-term future. So basically, now we're working on the green, on like the first part is kind of now, and then you can see on the y-axis we have like Sentinel-1, and it kind of means because like currently we're only working with this sensor, so all the work we're doing is probably working best for this. We hope it will be, of course, general, but it might have to be, adapted to that when we start adding more sensors. And then we have something about the general structure. We have something about some additional methods and other stuff. And basically what we're working on now is also what you maybe got from the hands-on session if you attended that we are working on the INSAR and testing especially. And then also we're going to have to do some restructuring. Oh, what's that? What's happening? No, okay. So is it? That's something. Okay, something. Sorry. I got distracted. Okay, so we have to restructure some stuff, and we will probably also work on doing like an interface for some of the things we're working on, and then we have some optimization. Then kind of soon we would like to start working on like downloading data more easily, because it's very useful for like end users. Basically, you can make like API calls to download the data more like automatically. And then we'll start working also on the ground range detected products, which is basically, so what we showed the other day was like how you work with the phase of the image. But this is the work with the amplitude, so it's also pretty important. Actually, most people work with this data, so it's kind of very obvious to start working on this. Then in the, let's see, oh yeah, then below there is the general structure, and then we will start adding like other Julia packages for more functionality. We were talking about, for example, whether we should have a dependencies on the raster.jl, for example, for downloading DEM and getting that in a kind of common format, but some stuff like these things. And then you can see down the line, we have a hope to add the sensor ISI. I will come back to that in a second. And then down here, we see that over like the whole process, we hope to kind of help contribute to a general ecosystem. So the hope is that this can play a part in a kind of larger ecosystem around using SAR data. And this kind of consists of these 4 boxes, we think, both engaging the SAR community, and that's some of the people here that are already working with SAR. And then we were kind of discussing like how to get people to, because the difficult thing is like some of the algorithms in this field, they're quite complicated. You need actually to work on them or really know what you're doing to get it to work. But the thing is, most of these methods is already very, very well established. So it's neither research or like, it's kind of in the middle. So it's actually a good opportunity is to see if we can get students, like master students or something, who are interested in learning these specific methods to work on this basically, and hopefully they could contribute. That's kind of at least how me and Simon and Christian have learned a lot, and also Iga, I guess. I know just because I know Simon and Christian very well, but all of us have learned these things ourselves. So it would be kind of an obvious, I think if we can get some students to get motivated to add some of the more advanced algorithms. And then we also gonna work like very much focused on like who the early adopters are. So what is the need from the early adopters? Could both be in terms of like default settings for like the data products, but it could also be in terms of like what we actually end up coding up. And then we hope to be able to empower the contributors. So a good example would be some master student has implemented the very basic algorithm or like a good algorithm in Julia, but it's not right package ready. It's just kind of a script or something. And then we can really help maybe, hopefully, to get them to learn how to contribute as a developer basically to the package. Yeah. And then hopefully soon we will also add this, like relatively soon, but like the next step, so to speak, is kind of add the sensor, the ISI sensor, and it will come in here in the package in the future. So basically ISI is very high resolution SAR data, so it's very interesting for many people. And here you can see, I think it's a ship. Yeah, and you can see it's very kind of high resolution compared to the Sentinel-1 data. Do you have a comment? No? Okay, so Iga will just tell you a little bit about some applications. Oh, sorry, one thing I forgot to mention, the methods. Sorry, it's just like the blue purple part. It's basically like in this ecosystem, because we will basically handle a lot of the data. So what will happen is also depending a little bit on like whether somebody will come in and build like persistent scatter interferometry in this ecosystem or something like that and want to contribute with that, then it will probably be another package, but maybe it will also kind of have to work together somehow. So we will have to see what happens. It depends a little bit like on what users will start adopting in this ecosystem, basically. Yeah.
Okay, so I'm gonna say a few words about the possible applications of the Air Center. So Air Center strongly support the SARProcessing project, and we want to take an active part in the development and then in the actually use of the method and the package. As was mentioned before, SAR data are extremely computationally demanding because each pixel of the SAR image consists of information about the amplitude and intensity. So we see a lot of value in doing this work in Julia. A flexible package for SAR data processing will facilitate and greatly accelerate our data pipelines and the workflow in our organization. One of our area of application is persistent scattering interferometry. We would like to use the method for port monitoring to deliver millimeter scale deformation over large spatial areas like ports or airports. Yes. Another area of application is soil moisture content and estimation. We have one ongoing project about detecting fungus spores on the fields. We are working on finding, well, they occur when certain weather conditions occur for at least 3 days. We are trying to see if there is any correlation between the fungus spores and the soil moisture content in the soil. So this is also a possible thing to do with SAR. Then the last but not least, vessel detection. As you already noticed, probably, we are in the middle of the ocean, of the Atlantic Ocean, and it makes a lot of sense for us to track vessels and also the backscatter signal of a vessel is really good with SAR data, and we would like to use this information and include them to our projects at Air Center. Now we will go back again to the package itself.
Yeah, so we're just wrapping up now, and basically the one I also just mentioned in the final part was the user-driven part of the kind of the whole ecosystem. So for example, persistent scatter, speckle filtering, and differential interferometry, or object detection, which is some of the things that Iga just mentioned as applications. And these will basically be user-driven, which means that it's probably not so much us that will drive the development of these things, because we need somebody with the expert knowledge to do this. So actually, we are also like kind of wanting to put up out an open question. You're also welcome to, maybe if you get an idea later, to come and talk to us. But basically how to best engage both the SAR community and go into Julia, but maybe also getting some people who's interested in remote sensing in Julia to get to work to SAR with SAR, but like how to kind of tackle this this challenge of having like both a very complicated algorithmic part in the backend, so to speak, and then also having people to go into Julia, which is a general, I guess, challenge in the whole community, right? To get people to adopt Julia in general, which I guess is going forward, but it's just, I guess, some people might have some experience. So if there's any input, you're very welcome to tell us. Otherwise, we are wrapping up and open for general questions as well. Yeah, so that's it. Thank you.
Thank you. Questions? Comments? Suggestions?
Felix has a comment. Maybe he needs the microphone. Yeah.
It's more from the other side. What things could you need from the Julia Geo community to push this forward?
what we could need from the Julia community.
Yeah.
I guess actually, I mean, what would be really nice, in my opinion, I think Simon agrees, and Christian Iga is related to this thing about the general structure of the package and some of the things we're doing. I mean, structurally, because it's the first time we built a Julia package, so we might be doing something horribly wrong. So it would be nice if somebody would give us a hint if that's the case. I don't know if you have any comments over there.
I think so already, like, being here and just being part of the ecosystem, we already learned quite a lot that we'll go back and implement regarding like different packages. But yeah, I think we will need to help in the future from the Julia community, again with the general structure, and then also like ensuring that we make kind of nice interfaces with some of the other common packages, so it becomes easy to use SARProcessing to do some of the initial, let's say, inferograms and like derive some of the data, and then take this information into geodata frames or rasters for further analysis, or like once you get to the point where you're fusing it with the other data. From the SAR community expecting, it would be nice to have somebody who wanna implement terrain corrections. It would be nice to have someone who wanna implement face unwrapping. It would be nice to have someone who would try to like. There's Felix, you yourself showed a long list of SAR sensors. Integrating each of these SAR sensors in the package would also contribute. So in that sense, we can find something. Yeah.
And one more thing I thought about is like actually someone like yourself, Felix, if as soon as we are ready, if you start using the kind of package for getting the data you need, that'd be very nice, because yeah, then we'll figure out what's not working very quickly. Yeah.
There are two questions from the chat. What are the next sensors you are looking at including? Do they include TerraSAR-X and RadarSat-2?
What are the next sensors?
Yeah.
And whether they include TerraSAR-X?
If you are planning to include TerraSAR-X and the RadarSat-2.
Yeah. Do you have a?
Yeah, I have. So we would like to include all of them, but we cannot include all of them at this. I know we don't have the time to do it ourselves to start with. If I don't think we took ISI as an example, but once we get to the point where we want to add a different sensor, it's very much driven by the need of the person who are developing, and like the person who are contributing, or some early adopter users. So we are open to having like a discussion about like which sensor to include in the chat, and especially like if you're really passionate about a sensor and you know a bit of Julia, you're welcome to become part of the ecosystem and contribute with an interface for that sensor. Personally, I don't have any like strong preferences to any of the sensors, but if a strong preference arises in the early adopters or in the contributors, of course, that's the one we're going to prioritize. We just put like adding a sensor, another sensor a bit early, because it could also be a good way to kind of validating some of how flexible we have structured the package. So like making sure that it supports multiple sensors early on. But that's more from the architecture, the package architecture view, that it could be nice to have at least one additional sensor quite early, just to make sure that it is that the code is written in a way that supports multiple sensors early on, and not something we add in the very end.
Yeah, and then there was a question online about the SBAS interferometry, and currently we don't have any plan to do that, but it would of course be nice. And again, as this person online is saying, if it's interesting, it's very nice, because then we know that maybe it's something we can either work on, or we can start working with this person online with. He's also suggesting some collaboration possibilities. So yeah, that's from the online, from the chat. Yeah.
You mentioned, so thank you so much, and very good. And thank you for sharing the roadmap. I think it's super useful to have this. Thank you for sharing. You mentioned the building of a community, a crucial aspect of this endeavor. I'm glad you're thinking about this explicitly. If there's anything that we can do to help as users of the package, we will certainly do our best. You mentioned also a critical element, which is architecture of the package. So we have Simon here, who's is the driver, the main driver of probably one of the largest ecosystems in Julia, sub-ecosystems within Julia, with Maki. So I don't know if he has some advice to provide at this stage.
So this is very far out of my domain. So I can't really judge it very well, but I think my biggest advice is just the community building. Go to the forums, ask a lot of questions, because I've always been super surprised how much feedback you can get and how many packages you actually suddenly pop up that are super helpful. And people just giving super helpful advices on how to structure things. So I think the Julia community and the forums are amazing, and they have been helping me a lot with Maki to structure everything. But yeah, I can't give any concrete input here because I don't really know the domain.
Thanks. Yeah, that's some good points. We can actually, I think once we have the kind of first sort of release, it's definitely something we should start pushing more for, like getting more in touch with the community, because we haven't done that so much yet. But also it's a bit easier, I think, when we have a little bit of like the basic stuff, because we actually did a post at some point, but it was like we didn't have anything at that point. So yeah.
I think it's also yeah, just being I think we will be more active on the forums going forward. It's always yeah, it's easily like to get the tunnel vision on like porting some code you have and doing and then forgetting. So it's really good advice, and we will take it up and start posting more things and more questions. So thank you.
Hey, yeah, so great stuff. I was just going to mention that so I'm involved with a few NASA projects and groups, and I'm sort of expecting that they're going to be quite interested in this. I'm assuming that you're welcoming everybody on their side to contribute, and I wanted to give you a chance to speak to that.
Yeah, thanks.
Thank you.
That's a good suggestion.
That would be really nice.
Yeah.
Okay, cool.
Thank you. That's it. Yeah,
Thank you.